Hey everybody, welcome back to my channel. Today we will be learning about proportion. Now in our last video we learnt about ratios and we saw it with a very sweet example of a carrot halwa. Now in that example we learnt that we needed 2 cups of carrot and 1 cup of sugar, and when we increased the quantity we needed more cups of carrot halwa, so we increased the number of cups that we had for carrot and for sugar simultaneously. We had to multiply on both the sides. Now this forms the basis for our proportion. Let's continue with the same example. So we have 2 cups of carrot, 1 cup of sugar. Now let's say I want to increase the quantity. I want to increase it to 10 cups of carrot. So I write down 10 cups of carrot. So how did I get 10? I had to multiply 2 5 times. So the same 5 times will be multiplied with sugar as well. So you now get 5 cups of sugar. Now let's write this in terms of ratio. I had 2:1 as the initial ratio. Now when I multiplied it with the 5 factor, I will have 10:5. So these two ratios, 2:1 and 10:5, are the same ratios with different factors of multiplication. Now that means both of them are basically the same ratio but having different factors of multiplication. So such ratios are called as ratios who are in proportion, and the proportion symbol is this. So in proportion we have 4 terms. Now in this case it is 2:1 and 10:5. 2, 1, 10 and 5 are the four terms, and these 4 terms are called as the terms who are in proportion. Now if I generalize it and write it as A:B is proportional to C:D. I am generalizing it and writing it in terms of variables. So A and D, the two variables which are there on the extreme ends, they are called as the extremes. Extremes, and the ones in the middle are called as the middle terms. Middle term, we can also call them as means or mean, right? So the extreme ones A and D are called as the extreme terms, and the center ones are called as the mean terms B and C. Now how do we find out if the 4 terms are in proportion or not? Now let's come back to the same example. 2:1 is proportional to 10:5. Now if I write this in terms of fraction, I'll write this as 2/1 and 10/5. Now if the two ratios are in proportion, then I can say that 2:1 and 10/5 have the same value. That is, when I reduce them, I get the same numbers again. Again this also gets reduced to 2/1. So I can write that these two fractions are equal to each other. It's just like the fraction that we have. Now I can also, when I cross multiply the terms like this, right? So I get 2 into 1 is equal to 2 into 1. Now that is also same as writing 2/5 is equal to 10/5. Now when I write like this, I can say 2 into 5 is equal to 10 into 1. Gives me that means 10 is equal to 10. So that is correct. Now again, generalizing it, we can write A:B is proportional to C:D. Again, coming back to the generalized form, A divided by B is equal to C divided by D. So here I can write A into D is equal to C into B. Right, so you can see now the product of the extreme terms. We have the extreme terms A and D, and the B and C are the mean terms. So product of the extremes is equal to the product of the mean terms. This is a very important concept in proportions. Now let's look at the definition of a proportion. Now we'll say that if two ratios are equal, then they are in proportion, and we use the symbol. This is the proportionality symbol, or we can also use the equal to symbol as we just saw. The first and the fourth terms are known as extreme terms. So A and D were extreme terms and C and D were mean terms. So if we write A is to B is proportional to C is to D, A and D are extreme terms and B and C are mean terms. So we also saw that if the product of extremes is equal to the product of means, then we can say that the two ratios are in proportion. Now let's look at some of the examples and how to solve them. The first question says there are two ratios and we have to determine if they are in proportion or not. So the first question, now as in the term of ratios has the units has to be equal. So here we have 25 centimeters and 1 meter. So 1 meter is also 100 centimeters. So we can now convert this and write it as 100 centimeters. And the second ratio is 40 rupees is to 160 rupees. So this is in the same unit. Now, there are two ways in which we can do the same question. We can write this as 25 is to 100 and find out the simplest form of the ratio. So, this is 1 is to 4. The same thing can be done on the other side. 40 is to 160. Again, dividing on both the sides with 40, it's 1 is to 4. Hence, now we can see that both of them are in proportion. So, here we can write 1 is to 4 is proportional to 1 is to 4, or we can also write 25 is to 100 is proportional to 40 is to 160. This is the first way. The second method is just like we saw, product of extremes is equal to product of means. So we'll find the product of extremes, which is 25 into 160. Which is equal to 4000. Right, same thing, product of means, we can write it as 100 into 40. Again, this gives us 4000. So hence we can say that since the product of extremes is equal to product of means, these two ratios are in proportion. Now let's see the second example. So the next example, 2 kg is to 60 kg and 25 kg is to 625 kg. Now let's look at both the methods. 6 is to 2 is to 60. Since all of them are in the same units, we don't have to worry about changing them. 2 is to 60, reduce it to the simplest form, we get 1 is to 30. And the second one, 25 is to 625. Now here 25 is the common factor. So dividing both the sides, 25 by 25 1 and 625 by 25 gives us 25. So here also clearly we can see that they are not equal. They are not in proportion. Let's look at the second way of doing it. Product of extremes. Now product of extremes, 2 and 625 are the extreme numbers. 625, this gives us 1250, and product of means gives us 60 into 25, which gives us 1500. So again, the same result, product of extreme is not equal to product of means, hence they are not in proportion. Now let's look at another example. Here we have been given that the ratios are in proportion. So we have to find the value of the unknown there. We have 55 is to 11 is proportional to x is to 6. Now, we also know that product of means is equal to product of extremes. So, let's see, product of extremes is 55 into 6. These are the extreme terms. These are the extreme terms and these are the mean terms. So, this is equal to 11 into x. Now, so we can write this the other way also. 11x is equal to 55 into 6, and now we can also write dividing by 11 on both the sides of the equation. We can have 11x by 11 is equal to 55 into 6 divided by 11. Now this gives us x, and here we have 11 one time and 11 five times. So we have 5 into 6, 30. So the answer becomes 55 is to 11 is equal to 30 is to 6. This is your two ratios which are in proportion. Now that we have seen proportions and how to find if ratios are in proportion, where do we exactly use them and why do we need to study proportions? Proportions, let's take a look at some of the scenarios. The first scenario we have is the number of people who are being served food. Let's say there are lesser number of people. So the food served to them is comparatively less. If the number of people increase, then the food which is served also increases, assuming that each of them have the same quantity of food. Now, that's one scenario. The second scenario, we can look at the map drawings. Now, in a map, keeping the same scale of the map, like let's say 1 centimeter on the map is equal to 10 kilometers. So, if I have to represent a distance of around 200 kilometers, on the map it's 20 centimeters, or if I increase the distance between the two places, the distance on the map also proportionally increases. So this is another use of proportion. The third example, let's say a person is driving at a constant speed. The speed is not varying here. We are assuming that the speed is constant. So if the time increases, he is driving, and at 1 hour if he covers 60 kilometers, 2 hours he will proportionally cover 120 kilometers. So he is, as the time increases, the distance has also increased. Now let's look at one example question with this scenario. We have on a map a distance of 50 kilometers is represented by 4 centimeters. So on a map, let's draw a map, and on that we have 2 points are represented, A and B, and we have another point, let's say C. Now the distance between A and B is 4 centimeters and the distance between A and C is 6 centimeters. But the actual scale is 4 centimeters represents 50 kilometers and 6 centimeters represents how much? This is the question. Now how do we solve this question with the help of proportions? Now we always have to remember that ratios have to be written in the same unit. Since we can represent kilometers in centimeters also, we can write, there are two ways of doing the same question. We can write 4 centimeters is to, now 50 kilometers will be represented in centimeters. So we will have to do the conversion. 50 kilometers, first let's convert this into meters. So that becomes 50,000 meters. Now 1 meter is also 100 centimeters. So 50,000 meters will become right. So this is 50 lakh centimeters. This is a one way of doing. Now the other way of doing is we do not need to convert. We don't need to convert. We will look at two ratios which have the same unit. So let's say we have 4 is to 6. We write two numbers which are already in the same unit, and then we have 50 kilometers is to the unknown, the one we need to find. Alright, so we now have 4 centimeters is to 6 centimeters and 50 kilometers is to an unknown value. And we already know that they are in proportion. So we need to find the value of this unknown. Now again, looking at product of means is equal to product of extremes. We can have product of extremes is 4 into x, the product of extremes, and that is equal to the product of means. So that is 6 into 50. So now dividing by 4 on both the sides, we have 4x divided by 4 is equal to 6 into 50 by 4. Now that gives us 2 is the common factor, 6 and 4. So then 50 and 2 also can be divided. So 4 2 ones are 2 and 25 times is 50. So 3 into 25 gives us 75. That gives us x is equal to 75 kilometers, because the unit for with 50, the ratio is 50 is to x, so x becomes 75 kilometers. So now that our unknown, the 6 centimeters represent 75 kilometers. The next topic that we will be looking at is the unitary method. Now in unitary method, unit, the word unit means one. So what we will do in unitary method is to find the value of the one unit and then you can multiply to find the value of more of them. So this is the definition. We have the method in which we first find the value of one unit and then the value of the required number of units is known as unitary method. To explain the unitary method, let's look at this example. We have the same example again. So 4 centimeters is represented. 4 centimeters is representing 50 kilometers. Now, how much will 1 centimeter represent? So, 1 centimeter is going to be represented by 50 by 4, right? So, 55 by 4 gives us 12.5 kilometers. So, 1 centimeters is representing 12.5 kilometers. This we have got the unitary value, the value which is 1 centimeter. So, 1 unit is representing 12.5 kilometers. Now we can multiply for required value. The question asks how much does 6 centimeters represent. So we can say now 6 centimeters is going to represent 12.5 into 6 and that gives us 75 kilometers. So here we come to the end of this video. In this video we looked at two very important concepts, proportions and unitary method. Proportion is nothing but two ratios which have the same common factor, and two ratios can be said they are in proportion when the product of extremes is equal to the product of means. Also in unitary method we find the value of a single unit and then we will multiply it with the required factor to get the value. So I hope you like my video. Please like, share and subscribe, and let's see you in our next video. Thank you.